Yes. So I already sent you these questions. I think I updated the rate of change file, right? In the rate of change, I realized that I didn't give you this type of question, which is visualize it yourself, draw your own diagram kind of questions. Okay. So let's just do them one by one. Okay. Question 20. You haven't tried, huh? I'll just go through it already. Okay, I took it from online source. Okay, so and I modified it a bit. Okay, so let's take a look. So a police helicopter, it's flying at 200 kilometers per hour at a constant altitude of 1 km above a straight road. So straight away, straight road, draw a straight road, something like this. Then helicopter, don't need to draw a helicopter, just draw a cross. All right. Then it's at an altitude of 1 km. So label, maybe you drop a perpendicular like this, 90 degrees here. Then you label the length as 1 km. Constant. Then it uses a radar. So probably it scans in a sector kind of shape, watermelon shape, scanning through to determine that an oncoming car is at a distance of 2 kilometers from the helicopter. What does that mean? It probably means that the car could be directly below, but that would be too simple. Usually we'll assume that it's not directly below, so that there will be a distance in red color here. That is how many km? 2 km. Following so far?
Yeah.
Then let me just label helicopter and car. Maybe it's good if I label the points. I'll call this point H, point C, helicopter car. What else? And that this distance is decreasing at 250 kilometers per hour. Is there a typo here? This distance is decreasing at 250 kilometers per hour. That doesn't sound right. Let me think of it. I think I meant 2.5. Sorry. This one. Let me just change it. 2.5. It's 250 a bit too much. Then you want to find the speed of the car. How? What should you do? Speed is what?
Speed of the car, distance over time.
Yes. But did they mention that the speed of the car is a constant?
No, because they said that distance decreasing. Right, distance decreasing.
Distance is decreasing.
Wait, when it says it's exactly 2 km from the helicopter.
At a specific point in time. That's what they mean.
Oh, but like how do you know that they're not saying this one? I mean, I know it's this one because I mean you say it's this one. Yeah, it's this one. But then how do I know?
How do you know? Let me see.
Yeah, because I think if I read this question myself, I would think like I wouldn't know which one it is.
Usually when we say distance, right? Think of it as an x and y axis. X axis, y axis. Then distance between 2 points is a shorter straight line.
Okay.
Yeah, distance is usually the
makes sense.
Straight line. Yeah. Okay, it's just a convention. Sorry, maybe I wasn't clear in the question.
But then the distance.
And this is decreasing at 2.5 kilometers per hour. Okay. So what does it mean? It means that let me think a bit. Oncoming car is at this. Okay. This distance is decreasing at 2.5 kilometers per hour. Means that we probably need to replace some of the lengths with variables. This is at a particular point in time. But we want to find out the speed of the car, which is really just distance divided by time. But the speed is definitely not constant because there is a okay. It's actually this question not clear. Did I change it correctly? Right. Okay. Yes. Correct. Okay. To find the speed of the car, it's really just the rate of change of the distance with respect to time, and the distance here must be this part here, right? Because a car only travels on a road. Does it make sense?
Yeah.
So we should label this length here as x. Okay, so what is the question really asking you to find out? Is to find dx by dt. Because dx by dt is the rate of change, right? What else? We also know that this is 2 km at a point in time. So we cannot label it as 2 km because it's changing. Probably the car is maybe moving this way. Then the helicopter, it's, let me read the question carefully. Flying at 200 kilometers per hour at a constant altitude above a straight road. So maybe it's traveling this way. Does it make sense? Because you must maintain a 1 km at constant altitude. Then you end up with a distance like this. Like if you can visualize what's going on, the helicopter moves a bit to the left, the car moves a bit to the right. So the car is here, the helicopter is here, H prime, C prime. Then you end up with a new distance, then a fixed 1 km altitude, and this X here at the bottom. Maybe I'll use red color. Maybe I'll use blue color for this one, for X. Let me just change to screen mode. Okay, change it to X. Then blue color, so I'll label here as blue color as well. Can you see that the red color is getting shorter and the blue color is also getting shorter? Because the helicopter maintains a 1 km altitude, then the car is moving, and this is a police. So you are trying to get close to the car. So it would mean that the car moves this way, the helicopter moves that way. So they can move closer to each other. Does this make sense?
Mm-hmm.
Okay, so that means that the red color length and the blue color length is changing. Maybe I should have labeled this as blue color. Okay. So essentially what you get is a special kind of triangle. What kind of triangle? Right angled triangle, right? And also, oh, I forgot to say this one. At a point in time, it's 2 km, right? But it's changing. It's changing, which means that it is not a constant, but rather a what? It's not a constant 2 km, it should instead be a variable, right? It should be a variable. So that means that we shouldn't label it as 2 km here. This is wrong. Maybe I'll use black here and cross it out. Instead, it should be a variable y. Km, x km. Okay, I'll ignore the units. Ken, is that okay?
Yeah.
Then if you look carefully at this triangle, it's right angled triangle, which means that you will need to use what kind of theorem?
Pythagoras.
Pythagoras. So let's write down the equation. So we now have a relationship between the x and the y, x squared plus y squared. Oh, sorry, x squared plus 1 squared equals to y squared. Agree so far?
Okay.
Yes. So what else is happening? Let me see. We know. Sorry, did you hear that announcement? No. Okay, never mind. It was from my phone. Okay, good. Cannot hear. So this is first fact that we should know. What else do we know? Let's read the question first. Police flying at 200 kilometers per hour. So that means it's moving this way, right? Maybe I'll draw. Use a different color. Maybe I'll use pink color. It's moving this way. 200 km per hour. What else do we know? We know that the car is also traveling. It's probably going the opposite direction of the helicopter. Then this is traveling at a certain rate. Okay, they didn't tell us what is the rate that is changing. So it's the dx by dt we're trying to find. Let me just write this down. Want to find dx by dt. What else is given? We're given that this distance is decreasing at 2.5 km per hour. Okay, 2.5 km per hour. So that means that the y is changing. So what do we know about the dy by dt?
dy over dt equal 2.5.
But here you must be careful. Positive or negative?
Decreasing negative.
Must be negative. Yes. Okay, good. This one rate of change question. Okay, we have what's given already. These two. Right. The two ticks. How to continue?
We have this, then we need dx over dy.
So which equation will be useful?
This one.
This one. Maybe it's easier if I just label as equation 1 and 2. Okay, so let's start with 1. Let's start with 1. We know what you need at the end of the day already, dx by dy. Okay, this is what you need. What do you do? Yes. Hey, when you take square root, you need plus minus.
Oh yeah.
But x is what? X is a blue color length.
It can only be plus.
Yes, correct. So that's why you reject the negative. Okay, I know I'm being a bit strict, but yeah, that's the general rule you should remember. Square root, you need plus minus, then drop the negative. Carry on.
Wait, I don't like the square root sign.
Yeah. Good. Right, test. Am I still connected?
Yeah.
Okay. Then what do you do now? You want to find dx by dy.
Differentiate.
X on top, y below. X on top and y below. This one, upside down.
Oh wait, lol.
Yeah, because you make x the subject, so x has to be on top, y below. A bit unconventional, but correct.
Half.
Bring down the O power.
And square root.
And
and differentiate inside. But then, wouldn't that just be?
which is
Wait, yeah.
with respect to y. So there's a y square minus 1. Differentiate y square, you get?
Wouldn't that just be? Wait, am I not thinking correct? Wait,
I don't know what you're saying. You haven't
wouldn't that
finished
just
your
be?
0. Wrong.
Okay, then it's 2y.
It's 2y, correct.
Wait,
Because
why am I confused? Wait, what is this? dx or
I think it's because you are writing it very messily. The dx by dt is throwing you off. So
okay.
Let me rewrite what you wrote. Okay, x squared equals y squared minus 1. Take a square root plus minus square root y squared minus 1. But you have to reject the negative. So you just keep the positive. Square root, reject x equals negative square root y squared minus 1. Since x is a length, okay, sorry for my cursive, then dx by dy, you are writing, oh, this is actually a power half, right? So I can rewrite it as y squared minus 1 to the power of half. Differentiate that, bring down the O power. keep the bracketed expression y squared minus 1 from the half, you get a negative half. Bring down the old power minus 1 to get the new. Then you multiply by, okay, help me to clear your writing.
Oh, yeah.
And carry on. What were you saying?
N times 2y.
Yes. Okay, very good. So times 2y.
So
Differentiate y
just
squared, you get
y.
2y. Differentiate minus 1, you get 0. Okay, then don't need. Then of course 2 and half cancel, you're left with y times y squared minus 1 power negative half. I'm gonna bring it down, which is y squared minus 1 power positive half. But positive half power, okay, I'll keep it first. Positive half power is the same as square root. Can?
Okay.
This is very unconventional because everything is in terms of y. You have chosen dx over dy. Okay lah, can, it still works. Now let's focus on the goal, which is to find dx by dt, how fast the car is moving. So that means you can do chain rule, introduce, color code it, introduce the dy, so they sort of cancel off, and over dt. Dx over dy, we already have an expression there, just substitute in with y over square root y squared minus 1. But what's dy by dt? Remember it was given. dy by dt is negative 2.5. So we're going to use it. Let me try and squeeze everything on one page. This is a bit messy. Okay, something like this. Okay, wow, messy. Let me write it neatly. Okay, then carry on. And dy by dt was what again? It was negative 2.5. So bracket negative 2.5. But this is when, but sorry, this negative 2.5 only occurs when what happens? When it's exactly 2 kilometers from the helicopter. In other words, when y equals to?
When y equals to 2.
Correct. Okay.
So sub y equals to 2.
Yes, correct. So we should,
What the hell?
to be more precise with our working, we need to say vertical line y equal to 2. Vertical line y equal to 2. Vertical line y equals to 2. Actually, at this stage, can just sub in, so you don't write the vertical line. Just directly sub in the y with 2. There's no expression for dy by dt. If you want to keep this vertical line y equal to 2, it must be a general expression. So you have to write something like y over square root whatever times dy by dt. Keep the dy by dt, and vertical line y equals to 2. Then you substitute y with 2, dy by dt with its value when y equals to 2. Then the rest just simplify a bit. I'm sure you know how to do the rest. 2 squared 4, 4 minus 1 is 3, square root 3 times a negative 2.5. 2 times negative 2.5 is negative 5. Negative 5. Does the answer make sense? Why got negative?
Does the answer make sense? Y got negative?
I was assuming you would say yes immediately. Well, why?
Speed what? Wait. Let me think. Wait.
Maybe the phrasing is not correct. I should have said velocity.
I mean, if you say it's velocity, then yeah, makes sense.
Why negative? It's because the car is moving closer to the helicopter, so its distance is reduced. It's reducing. So decreasing function means that you should have negative rate of change. Okay, can? Yeah, that's the answer. If you want the units, it will be km per hour. Does it make sense? I guess so, roughly. Yeah. You can rationalize the fraction if you want to, but I'm not gonna do that. Just multiply square root 3 on top and bottom. Okay. The numbers probably don't make sense, but yeah, I'll work it out next time if I have time. Okay, let me just bring it all on the same page so I can save some space. Okay, Ken, that's our first question. Okay, still got 2 more. Ready to move on?
Why does it feel so different?
Oh, because you yeah, that's exactly the point of the 3 extra questions. Because you have to make use of a special equation and you need to draw a picture. Also, there's an extra variable t involved, right? Which is hidden from the diagram. Here's y, here's x, here's a constant 1. There is no t. But as long as you know the chain rule trick, which is to do this thing, whatever variable they throw at you, it doesn't matter. This t, so what if there's a t? As long as you know how to substitute dy by dt, then you're good to go. Okay? Make sense?
Yep.
Can? Okay, let's try the next question, then you'll see. Let's see. This one is the boat question, right? Okay, boat question also very common. Do you see the video? Hey, I plugged it at the wrong question. Sorry. Let me crop it. Okay, there's a video. Okay, give me a second. Let me find the link. Okay, I'm gonna share my screen. Can you see? Is the screen being shared? Can you understand what's going on?
What's going on?
Yeah.
Like the guy's pulling the string.
That guy is me. There is a rope. There's a basket. Okay, I just got basket. It's just it's representing the boat. Okay, and you're tugging the boat along the string. So what you notice is that at the beginning, okay, if I can just pause it at the right moment. At the beginning here, it's like not taut, right? It's loose, not tight. So here the question requires you to assume that it is already tightened like this, fully taut. Can you see? Understand? Then you proceed to do the question. What shape do you see over here? As I move my mouse, what shape do you see here?
What shape? Like
visualize.
right angle triangle.
Right angle triangle, a cross section, right? This is like converting from a 3D diagram into a 2D diagram. There's a 2-dimensional right angle triangle. Okay, that's the key to this question. And as you pull the rope, what happens to this hypotenuse?
As you pull the rope?
A point here that's fixed, and then a point here that's fixed. As you pull the rope, what happened to this distance? This diagonal hypotenuse. Longer or shorter?
More from like this, then
it becomes steeper, right? But what about the distance, the length?
Does it shorten?
Yes, it shortens. Right, it makes sense, huh? This vertical distance doesn't change, right? Like if you can imagine a horizontal plane across here, you take a flat table across here, and then you measure the distance from the top here to the table. It's a fixed distance, which is exactly the same as the helicopter question. Like the 1 km altitude, but here it's not 1 km, it's some amount of cm, right? Can you visualize? At first it was like this triangle, now it's this triangle. Okay? Then as I pull it closer and closer, of course the hypotenuse gets shorter and shorter. And this horizontal distance here, like the x, will also get shorter and shorter. Okay? Understand the visualization?
Yeah.
Okay, stop share, go back to iPad. Give me a second to share my screen. Okay. And done. Okay, can you see the screen? Okay, good. Right, so a boat is put into a dock by a rope with one end attached to the front of the boat. Okay, so here is my boat. It is a rectangle. And the other end of the and the other end passing through a ring attached to the dock at a point 1.5 meters higher than the front of the boat. You know what? I'm gonna make my boat a bit simpler. This is my boat. It is just a horizontal line. Okay, heightless. Then there's a pier. Okay, I'll try to make it look nice. Oh, this one. Okay, not very nice. I can't draw. Something like this. Got a plank like this. Can you visualize the pier? Okay, here's the sea. Here's the sea. And you use blue color. Can visualize? Can Okay, then with one end attached to the front of the boat, so it's over here. And the other end passing through a ring attached to the dock. Okay, let's just assume that the ring is heightless. So somewhere over here, there's a ring. Okay. Then you try to visualize this. There's a right angled triangle over here. Can see the right angled triangle, pink color. Yes. Then the rope is this guy. This is the rope. Maybe I highlight. I don't wanna. I use a different color. Maybe I'll use blue this time. I don't wanna see already blue. I'll just use black. So this is the rope that's getting shorter. And since it's changing, right, let's just label it with a variable. Since we already use y just now, let's just continue. Label this as y. Okay. And what's going on with this rope? This y length rope. Let's read the question. And the other end passing through a ring attached to the dock at a point 1.5 meters higher than the front of the boat. Oh, there's a 1.5 meters. So where does this 1.5 meters refer to? It refers to this part here. Okay. This part here. So I label 1.5. 1.5. Is it clear? This 1.5. Can and it's a fixed length, right? Because the height of this pier must be fixed. Okay. Then the rope is being put through the ring at a rate of 20 cm per second. So it means that this length, somebody is pulling it in this way. So it's getting shorter and shorter. So at first it will be a triangle that looks like this. Then it will shorten into a triangle that looks like this. And then a triangle that looks like this. Can you see? Red becomes blue, becomes pink. As you pull the rope inwards. Make sense, Okay, good. So 20 cm per second. So that just means what? That just means here we have a cm. Please be careful. Here we have a cm first, and let's continue reading. How fast is the boat approaching the dock when 4 meters of rope are out? What does that mean? When 4 meters of rope are out? And also, what is how fast? How do you measure fast? It's actually referring to
speed.
Okay, yeah. But you need d something over dt. You got y, so what's the other guy? The partner of y is no. You measure the speed by measuring the diagonal distance, right?
dx.
X. So where is x? Look at the diagram. Exactly, it's at the bottom. Okay, let's label x here. Okay.
The
Get rid of the
4
C.
meter is the thing you submit.
4 meters. Yes, it is the when they I think what they mean maybe my English is not good. Please correct me if I'm wrong. When they say 4 meters of rope are out, what I believe they are saying is that when y equals to 4. When y equals to 4. So sub in y equals to 4 as our last step. Okay. So anyways, we end up with the exact same diagram. Don't need to think so hard. Just simplify this diagram. Oh, sorry, maybe I'll keep this at the corner. Just simplify the diagram. All you need is a right angled triangle. There's a variable y, there's a variable x. This is the rope that has been, what's the phrasing they used? Rope, length of rope that is out. out. Very funny word. Then x is like the distance. Just like the car and the bottom of the helicopter, or rather the bottom of the perpendicular dropped from the helicopter. That's the distance. Then this vertical one is a fixed 1.5. What's the units? Meters. Okay, this is given. One of the information. What else is given that I haven't write down?
The 20 cm per second.
So 20 cm per second. What is it? The rope is being put. So it's d what over dt?
T dy over dt, is
Correct. Yes. Yes. Good.
it? Then
Because this part is the y. But wait, here is meters. Here is cm.
so
Is that a fair comparison?
Change the meter to cm.
Yes, correct. Standardize one of them. You can also change cm to meters, but I prefer going to cm because less decimals. Okay, so 150 cm, right? So also here is y equals 4 meters. Maybe I put down the units, which is equals to 400 cm. So we need to substitute with 400 later, not 4. Okay. What else we have? 1.5 meters. Oh wait, sorry, I already wrote down. Here 20 cm per second. Okay, that's fine. Then we can proceed already. What do you? I wrote down given. I still need to find WTF one to find what Let me rearrange it.
Dx over dy. I mean dx over dt.
Dx over dt as the final answer, but dx over dy is an intermediate answer. But let me show you a different way to do it instead of x on top, y below, because that's a bit non-standard. Okay, let me show you how I would usually do it. What I'll do is I'll make y the subject instead. So let me. It's really just the same thing. From the right, from the right-angled triangle, I can get this equation, which is from Pythagoras theorem. Then I'll just make y squared the subject. I'm just swapping around the sides. Then I take a square root. I'll keep the 150 square because it's a very big number. I don't want to write so much. Then I'll just say reject negative root. Because y is a length. Since y is a length, and the length is positive. Then we proceed to find dy by dx first. So square root is power half, right? So I bring down the half, keep whatever is underneath the square root, copy and paste, put a pair of brackets around it. Power half minus 1 is negative half. Then you multiply by what? What do you multiply by?
Multiply by the differentiate the inside.
Yes, the derivative of the inside. So it's 2x. Is it correct if I do this? 150 power 2. So I bring down the old power and minus 1 to get the new. I get power 1. Is this correct?
No.
No, why? No man, power rule, bring down old power minus 1 to get the new. Why is it wrong? What's the rule? Why is 150 square? I'm talking about power, just bring down. Very good. It's a constant. It's not a variable to the power of a constant. It's a constant to a power of constant. So it's all still just a number, a constant. Differentiate constant, you will get 0. This is wrong. It should be 0. Okay, can. Anyways, it's just 2x. Yes. Then half times 2 is just an x, right? Half times the 2 here will give you the x. X multiply by x squared plus 150 squared to the power of negative half. Bring it down, you get x over x squared plus 150 squared to the power of positive half. But power half is really just square root. So square root x squared plus 150 squared. And then we are done for dy by dx. Is that the final answer?
Is that the final answer?
If you remember the question.
You have to sub in.
That's why you should write down this WTF. Wow, write down WTF, you still cannot remember. You must look back. Dx by dt is what you want. So is this the final answer? No. Continue. So you start with this guy, then what do? Split. Split. How? Hi. Split for me.
dx over dy times dy over dt. Then
Good.
dy dt you know already.
Good. Which
D,
is 20.
and then you just do 1 over dy over dx,
Yes.
which you can sub
First,
in that one.
1 over actually is just flipping the fraction
Flip
upside
around.
down.
Yeah.
Right. So that means this is actually this is getting very messy. Let me just copy the working and erase the rest. I'm going to do the working below here. Below over here. Yeah, so you just take the reciprocal, which becomes square root x square plus 150 square over x multiplied by 20. Are we done? No. Here, when you sub in with 20, that's for the case when,
When you sub in 20, that's for the case when when y equals to 400.
When y equal to 400. So you need to sub in y equal to 400 as well. So let's just do that. Sub in y equal to 400. Got line y equal to 400. Okay, that's technically not very accurate. I should do this instead. dy by dt. Then I can rewrite it like this. Sorry, I'm being a bit long-winded. You don't need to do this, but I want to show you the correct notation. So here you can have a dy, have a y equals 400, and times dy by dt, and y equals 400. Then this is the same as this guy when y equals 400, the square root something over x, and the dy by dt when y equals sorry, did I say 100? I meant 400. Yeah. When this one when dy by dt when y equals 400, you just replace it with 20. So don't need to write down the vertical line y equals 400 anymore. You can read this vertical line as substitute y equals 400, or under the condition that y equals 400. Over here, there's a problem. I want to sub in y equals 400, but I only got x. What do I do? Let me copy down the diagram first.
Sub y equals to 400 into using the Pythagoras theorem. You make the equation. Then after you sub y equals 400, then you solve for x. Then you sub the x value inside.
Very good, exactly. So let's just make x the subject first. So we get y squared minus 150 squared, and then I'm gonna skip the explanation about the plus minus. You know the reason, right? I dropped the minus because x is our length. Length is positive. So you just sub in with 400. So when y equals to 400, x will be equal to square root 400 square minus 150 square. I need a calculator for this. Let's see, 400 square minus 150 square, 13750. Okay, this is a very big number, but never mind, we have a calculator for this. Yeah, so that is x. Then you just have to say, you just have to substitute in with the value of x. So you can write the following. You can just write this same thing, but you replace the y equal 400 with x equals to square root of 13750. Then the rest is just substituting and simplifying. Can I leave that to you? Can I? Yeah, don't need to. The final answer is not so important. But okay, let's move on. That was 21. Let's go on to 22. Last one. Ladder question, also very common. So in a very unrealistic scenario, there is a ladder that is sliding down a wall. There is a very dangerous situation if you are using it to climb on top of a roof or something. But let's just imagine that somebody lets the ladder slide down the wall. You get what I'm saying?
Yeah.
Okay, so let's visualize. Here's a vertical wall, there's a floor. Let's just read the question first. Before I keep drawing. A ladder 13 meters long rests on horizontal ground and leans against a vertical wall. The foot of the ladder is put away from the wall at a rate of 0.6 meters per second. How fast is the top sliding down the wall when the foot of the ladder is 5 meters from the wall? So here, what they're saying is, first you have a ladder that's like this, okay? The base is in contact with the horizontal ground. Then the top is touching the vertical wall. Make sense?
Mm-hmm.
Then what you do is you slide it down. So maybe I'll use blue color, something like this. It's still the exact same length because a ladder length won't change so much. Okay, you can assume that a ladder 13 meters long stays 13 meters long. It just slides downwards. Okay, my diagram not so accurate. Let me try it. Make it look roughly the same length. So something like this. Black color and blue color are the same length ladder. It's just that the ladder slide down. So this part decrease, this part increase. What do I mean by this part and that part? I am actually referring to the length. Okay, maybe I draw a separate diagram like this. Hey, where's my, give me a second. I want to make it look a bit nicer. Yeah, like this. So you start from here, you turn into this. So what's really going on is that there's a y here, there's an x here, where y represents this vertical length, and the x over here represents the horizontal length. Right? Then as you slide down, the y decreases. It's a new y. And as it slides down, the x increases. There's a new x. Doesn't this remind you of the coordinate geometry question? Or the quadratic, this thing? Remember this question?
Mm-hmm.
X-axis, y-axis, and you have a triangle like this. It just keeps moving. Kind of forgot what are the exact details of the question, but something similar, a right-angled triangle that's changing in its vertical and horizontal length. Just in a more practical scenario. Okay, not really practical, but a ladder sliding down scenario. Okay, what else? Let's just fill in the blanks now with what we are given. Oh, I forgot to label one more thing in the triangle. Can you tell me what's the missing length? Got y, got x. 3 sides of a triangle. One side is y, other side is x. Third one is? Read the question.
Third one is 13
13
meters.
meters, yes. Here the question I was I just set to all meters per second. Don't need to worry about unit conversion. That's just an annoying thing you will have to worry about if you do physics or engineering. The units matters, have to be the same units. Here I'll just make it the same units because I'm just doing the math. Now, given what else are we given other than the x, y, and the 13? Okay, x and y actually you need to imagine on your own. So it's not really given, it's a deduction. What else are we given? Foot of the ladder put away, rate of 0.6 meter per second.
Zero 0.6 meter per second. That
So
is
d1 over d1.
the foot of the ladder. So means x, dx over dt. Is it?
Yes. Increase or decrease? Away from the wall.
Away, so increase. So positive.
So positive 0.6. What else are we given?
How fast is the top? WTF is.
So it's not given, it's WTF.
WTF is dy over dt.
What are we expecting? Positive or negative?
Expect negative.
Expect negative. Okay, can. Let's just write this down. Expect negative.
And
what
then
else are we
when
given?
x equals to 5.
So not just dy by dt, it's actually vertical line. What is it? What is equal to 5?
X.
X equal to 5. Correct. 5 meters from the wall. Okay, how? It's the same question. Once you draw the diagram, you don't need the question anymore. split. Yes. Good. Positive 0.6, good. Dy by dx. Yes. Good. You want dy by dx, y on top. Y on top means make who the subject? Y the subject. Easier lah. Y on top, Y the subject. Y is a yes, correct. Good. Let me just scroll down so you have more space. Yeah.
Wait. Hold up.
Too fast already. Good. Then chain rule. Minus 2x. Good. So negative 2x. That's why you will expect a negative. Simplify, continue. Just 13 squared minus x squared, right? Okay, good. Then finally substitute.
Sub x equals 5 inside. Then time in.
Then hopefully, okay, let's work it out. So it's a negative. Okay, I'll just write it down somewhere where I have space. Give me a second. How? Okay, so dy by dt equals dy by dx times dx by dt. Don't erase first. Dy by dx. Somehow you manage to eventually get this negative x over square root 13 squared minus x squared. And then dx by dt was, if I look at the given, positive 0.6. So I'll just sub it in with 0.6. But we also need to sub in with what? X equals to 5, right? So the notation wise, it will be vertical line x equal to 5, vertical line x equal to 5. I'm just going to be lazy, substitute x with 5 directly. Okay, then let's check whether we'll get a negative answer. Confirm will lah, confirm will. Because of the negative over here. Helps. Guarantees are, the T looks very bad. Guarantees, negative. Okay, this is negative 1 over 4. Oh, very messy. Negative 1 over 4, what's the units? Meter per second. Or you can also write ms power negative 1. Okay, both are fine. Understand?
Mm-hmm.
Yeah, so it's very simple. Just convert from a crazy, real life application question into a very simple right-angled triangle. Once you have a right-angled triangle, you know how to do the rest. Pythagoras theorem, label your y and x. You must know, label y and x first. Then you get your right-angled triangle. Then you write down what's given, write down what you want to find. Use the splitting trick when you're dealing with rate of change question, and substitute as the last step. I'm sure your differentiation technique is okay already. Very solid already. Just remember, differentiate first, substitute later. Okay? Okay, 3 questions done. Let's move on. What other homework questions did I assign you? Let me check first. 3 more rate of change, exercise 12A, exercise 12C. Okay, give me a second to get the file. How should I do this? Is it this guy? Yes, it's this guy. It's all upside down. Okay, never mind. I can just extract the correct pages. Exercise 12A. Why did I choose those questions? Let's see. Okay, wrong one. This one. Paste. Let me rotate this a bit. Ayo, very bad. Okay, here. Which is the question? Question 2DF, 4BDF, and question 5 and 6. Okay. Hey, wait a minute. Did I mark your?
This is the one I did.
You did already. Exercise 12A. Oh, 12C haven't do, is it? I can't remember. Let me just see. Did you do it already? Yes, you did it already. Oh, okay. Was there any wrong questions? No, everything was fine. Oh, sorry. Let's move on to 12C. Oops. Ayo. Bad. Delete this. I need 12C. Sorry, give me a second. Okay, where's 12C? 12C is. Where's my 12C? Here and here. Go here. Wrong file. This one. I need to rotate it. Oh my. How do I rotate it quickly? Okay, Ken, help see. What was the question? Question 1DEF. Okay, let's start there first. Okay. Okay, let's go. Question 1D, E, and F. Okay. Part D, find the coordinates of the stationary points of each of the following curves and determine the nature of the stationary points. So it's basically asking you to remember the DES procedure. Can you tell me what it stands for? D for?
Differentiate.
Yes, good. E for?
Equate.
To?
0.
10,000? No, 0. Very good. Then S for?
Stationary. What is S?
Equate to 0 means you differentiate already, you get some bunch of x equal to 0. You have an equation involving a x squared plus 2x plus 1 equals 0. What do? Last step, solve for x. Make sense? It's obvious once you see it. Very simple one. Okay, and then you also actually S need to have an extra S because you need to substitute the x back in to find the corresponding y coordinate. I'll just demonstrate for the first question. 1D. Y equals to 3x cubed minus 3x squared minus 8x plus 5. Very good. There is the equation. First step is D. D for differentiate. So dy by dx. This one very simple. I'm just going to go very fast. 9x squared minus 6x minus 8. Okay so far? Good.
Yeah.
Now we equate to 0. E for equate to 0. So please write down the magic word for me. Set dy by dx equals to 0. Maybe if you want to be more precise, it should be for stationary points, set dy by dx equal to 0. In order for you to be able to find stationary points, please equate the dy by dx to 0. This is the shortest way to phrase it already. For SP, set dy by dx equals 0. What does that mean? Means start with 0 lah. Then just take the answer from above, equal to 0. Once you have an equal 0, what do you think you want to do? S. What do you want to do? Stare at the quadratic equation.
Solve quadratic.
Solve it. Just use calculator. Take out a calculator. At this stage, I'm sure you know how to factorize and solve it, but we all are mature math students, we know how to solve quadratic equations already. I'm just going to use a calculator. So x equals to 4 over 3 or x equals to negative 2 over 3. Okay? Calculator? Good. If you really want to, you can factorize it. What would it be? I just divide by 3, bring over 3x, then minus 4. This one divide by 3, bring over, become 3x equal negative 2, bring the minus 2 over 3x plus 2, bracket 3x plus 2. You can check on your own, verify on your own that this expands to that. I'm not going to do it. Okay, moving on. So now that we have solved for the x here and here, that's not good enough. Why? Because they ask us to find the points of each of the following curves. When they say points, they're referring to x, comma, y. Y. Let me highlight the y, circle it. A lot of colors. Y. You must have the y. You must have the y as well. Okay. So then directly below, you write down the y. What is it equal to? You can just give the final answer straight away. Substitute 4/3 into all of the x. So for the first guy, it will be due to lack of space. I'm writing it at the right side. You don't need to show this working actually. It's quite simple. We assume that you know this. Okay, then just type in a calculator. I'm just gonna do that. 3 times fraction 4/3 to the power of 3 minus 3 times fraction 4/3 to the power of 2 minus away 8 times a fraction 4/3 and then plus 5. We get a negative 35 over 9, whatever the answer is. Then here you got negative. Do you need to reject? No, do not reject, please. Unless it's a practical question where x represents the length or something, then you can reject. Here it's not a practical question. Just follow the procedure. Don't drop any negative answers. So we just sub in with negative 2/3. Is it okay if I just give the just find the answer and put it down? Ken, how you understand what's going on, right? So let me just quickly get the answer. Give me a second to type in the calculator. Minus 3x squared minus 8 times negative 2/3. 2 on top, 3 below, and then plus 5. And let me just wait. Let me double check. Minus 3 minus 8 and plus 5. Answer 73 over 9. Very good. Are we done? No, because here, if you read the message I sent you, this is only the first half of the procedure. Okay. As maybe I'll put a subscript 2 here to tell you that you have to solve, set and solve. Yeah, you need to solve for both the x and the y to get the points. If you read the message, I sent Desta, right? Desta. Is it Dest? Oh, Desta. I can't remember exactly what I said. Is it Dest? What does the T stand for?
What does the T stand for?
Go open your phone and read.
So the T stands
Desta
for
2.
differential equal to 0, solve for x stable.
Read the whole sentence. Able
to determine the nature using first derivative test. Second derivative test can also help you to determine the nature.
Continue reading. Read the rest.
Don't need do both in the exam, but for now, since you're starting, maybe you should do both ways.
Yes, do both ways. Practice. Okay, so I'm gonna show you both ways. So the lame mnemonic I came up with, the star 2, the star 2, whatever it means. Okay, and a slash before the 2 to tell you it's option. It's option 1 or option 2. Option 1, option 2. Okay, TA is table method, which is the first derivative test. That's the formal name. If you want to Google and find YouTube videos to help you, it's called the first derivative test. Okay, let me write this down somewhere over here. TA is table, which is actually the first derivative test. You can go and Google for more resources. Then 2 here is just my way of saying second derivative test. Okay. I went through the concept last week already. So I'll just do the practice questions now. So finding the nature of stationary points. What do they mean by nature? Flowers and leaves, photosynthesis. No. Nature here means classify it into one out of among three types. What are the three types? Can you tell me? Three types of stationary points.
Increasing, decreasing.
Wrong. That one is
Wait.
rate of change. More than zero, increasing function. Less than zero, decreasing function. The derivative, more than zero, derivative less than zero. Those are for determining whether a function is increasing or decreasing using a derivative. It involves inequalities. That's a totally different topic.
Okay. Wait, then what is it?
Do, re, mi. A mountain climber, a trekker. Let me draw a nice hat for him. He's climbing up a mountain. Climbing up a mountain until he eventually reaches here, known as the
It's the
maximum point. Hey,
maximum point, minimum point.
Okay. What else? Hey,
Yeah,
my
that
name.
was-
I cannot forget. Okay. Then the last one. Most funny name. Inside, outside. No. In F L E C.
Inflection point.
Inflection point or inflection. I'm not sure. I can't remember which one is the American and British English spelling. But yeah, one of them huh? Doesn't matter. Okay. Inflection point. Okay. So yeah, I haven't shown you much enough examples for inflection point. So that's my fault. But let's just begin. So sorry, upside down. Max, min, and inflection point. So what is inflection point? It basically means the curvature changes from sad phase to happy phase or happy phase to sad phase. The point where the change occurs is known as an inflection point. Here in AMAX, we study stationary point, inflection point. In other words, you are both an inflection point and you are stationary, meaning that the gradient equals zero. Okay, let me show you some examples of inflection points. So if you remember this guy, what is this guy? Up, down, down, up.
Up, down, down, up.
Is my drawing very ugly? Oh no.
Sine curve.
Sine X, very good, yes. Okay, so at this point, can you see? It goes from this part is like a sad phase, that part is a happy phase. The point where it changes, this is known as a inflection point. Okay. Change from hee to sad. Or the other way around. Okay. The point where you change curvature. The formal way to say it, I'm not gonna write it down. Change in curvature. You can write it down if you want to. But because it's not the main point of AMAX. A main point is to focus on not general inflection points, but rather inflection points which are stationary. Oh, actually, you know what? Let me just give you one more example. Of course, cosine rule will also have inflection point, but one more example will be tangent. Let me try and draw the tangent graph quickly. So can you see the inflection point over? Not done yet. Let me draw one more like this. Can you see the inflection point over here and over here?
Yeah.
Can, right? This is sad phase, left half of a sad phase. This one is right half of a happy phase. Right half of happy phase. You change from sad phase to happy phase, then you are a inflection point. Okay, tangent curve. Let me just label it. But those those inflection points are, if you look at the gradient, it's actually like this. Can you see? Sorry. When you look at the tangent line at that point, it's like this. And the other one is like this. Oh wait, tangent we need to know. Maybe I should have brought this down. Whoops. Let me just bring this down. What's the difference between these two? Sorry, let me start over. Okay, sine curve, you got inflection point here. The tangent line at that point is like this. Agree so far? The pink color? The second example, tangent curve, you also got inflection point here and here, right?
Yeah,
so far?
but it's like going.
But the tangent is like this, horizontal, right?
Yeah.
In Amex inflection points, we only care about stationary kind of inflection points. In other words, horizontal gradient.
Okay.
Okay. That's all I wanted to say. Okay, Ken. All right. I'll talk more about the d2y by dx squared equal to 0. What does that mean later? It does not imply inflection point. I'll talk about it later. Okay, carry on solving the question first. After we found these 2 points, this is a funny notation to say it's xy coordinates, a pair of coordinates that go together. It's like the left half of a set. If you remember sets, like set, 1, 2, 3. We take the left half, we put it there. Then we call it a pair of coordinates. Okay, that's not important. Okay, moving on. So we need to figure out the nature. Method 1 is table. T for table. What is the table I want you to draw? Like this. 3 columns. Okay, maybe 4 columns. You know what? I'll make it double line. Like this. Double line like this. Can you see? This is for the labels. So over here, I want you to have x equals to, we're going to figure out for the first point, 4/3 and negative 335/9. The y coordinate, after you find it, it's no longer important. Just focus on the x, just x. Just x will do. X equal 4/3. Then on the left side, I want you to write x equal 4/3 with a tiny minus at the top. Means something slightly smaller than 4/3. And on the right, I want you to write down y equals 4/3 with a plus on the top. Makes sense, right? Because number line on the right side is positive, left side is negative. So here, right side positive, left side negative. Positive here, negative there. Left, negative, right, positive. Okay?
Okay.
Then on the left-hand column, I want you to write down dy by dx sine. Here, when x equals 4/3, dy by dx is definitely 0, right? Because that's where you, how did this 4/3 come about? It came from your first step when dy by dx equal to 0. So they must be the same. X equals 4/3, dy by dx equals 0. dy by dx equals 0, x equals 4/3. They are the same, equivalent, right? So that's why it's a 0 here. Now, I want you to pick a value of that is slightly smaller than 4/3, maybe less by 0.01. There's no hard and fast rule for this. What number would you like?
0.1.
Maybe 1.32, something smaller than 33. Okay, then okay, can we go with that? 1.32? And then the other guy, we go 1.34. What I want you to do is to substitute 1.32 into the into the expression for dy by dx, which is over here. Sorry. Okay. Can you do that for me? Substitute. What do you get? Oh yeah. Do you know how to use a variable function on a calculator? Like you can type in 9a squared minus 6a minus 8.
Oh no.
Can you just replace? Okay. Give me a second to share my calculator. I'm not sure about your calculator model, but for mine it can do that.
Mine is FX97SGX.
Okay, it should work. Hey, where's my calculator? 哎，不见掉。 Where did it go? My calculator disappeared. Oh no. Okay, this will have to do. It's a bit small, but okay. Can you see the calculator?
Yeah.
Okay, so this is online version. Let me show you how to do it. So what you want to do is to first press alpha and then you press this A button. Press equal and you get a 0. What this means is that you can imagine a box with a label A, and inside the box, what do you see? You see a 0 as a present. Now, if you want to change the present, change the contents of the box, you can press 1. Let's say you want to replace a 0 with 1 or any value you like. You can press shift, press the store button, if I can find it first. Here, yes. Because STO stands for store. So you see a STO at the top here, right? STO. Then all you need to do now is to press alpha. Did I do it wrong? Wait, let me think. Yeah, shift store and then press A. Yes, that's right. Just press this button, minus sign, but on top you can see a on the red color A, pink color. What this does is that it will store the value 1 inside the box labeled with an A. So the contents of the box labeled with an A will now be a 1. So if you press alpha, okay, let's just AC first. Press alpha, you activate all the red buttons. You click this button, you get A, you press equal, you get 1. So now you can, to make your life.
Wait,
sorry?
Do again.
Which one? Okay, let's say I change to 7. Let's say I change to 7. How do I do it?
Okay.
Press 7, shift A. Shift A. Why is it not working? Oh, alpha A. Is it alpha A? No. Oh, sorry. Shift store. My bad. Let me try again. You start by pressing a 7. You press shift. You press this LCL or wherever you see a STO button. You activate a STO. It depends on your calculator model.
Mine's mine. Oh wait. Oh no. Mine has STO, and then if you shift it, it says recall.
Shift and you press recall. Then okay. They swap the order. So then that means you don't need to press shift button.
So I press 7 STO A.
Then you pick the variable you like. You can pick A, B, C, D, X, Y, M, F. I pick A Then you will appear as arrow A. Means 7 is stored inside A. Then if you want to recall the value of A, you press alpha. You press A. What happens if you press equal? You get 7. So that means that now this variable A is a 7. So if I press, for example, 9A squared minus 6A plus minus 8, which is the derivative, if you recall, you will get the value where the x is replaced with a, where a is a 1. X become a become 1. Sorry, 7. I updated to 7. So once you have this, you can, if your a you want to have, let's say the 1.32. Right, remember just now we had a 1.33. We clarified we wanted a smaller number, 1.32. So we can just type in 1.32. Shift store A. This will be your A. Then all you need to do is to don't press the on button, please. Do not press the on button. You see the up arrow here? It means there's a history. Like you're on a web browser, there's a web page. You can go forward, backward. Press the up button, you'll get back this guy. Then you just press equal. You can press the left button, then equal. Left button will just go back to this page. Alternatively, and you can just go directly to this page while it's still displaying 391. Press equal. It will update the value straight away. So you don't need to go and 9 open bracket 1.32 close bracket power 2 minus 6 open bracket 1.32 minus 8. Very troublesome. This is to save time. Clear?
Yeah.
Okay, I'm just teaching you how to save time. So now you have a negative 0.2384. I don't care about the value. I only care about the sign. What sign? Plus or minus? Minus sign, right? So that means back to the table, I will draw a minus sign. Let me share my screen again. Minus, just draw a minus sign. That's it. dy dx sign is just asking for plus or minus. How about this for third? Positive 1.34. Can you try on your calculator? What value do you get? Or what's the sign?
So if I do 1, 3, 4, 4 press, then
Shift
A,
store A. Shift store A. Or depends on, maybe you don't need the shift.
store A, K.
Then press the history, go to the history, go to 9A square minus up. Press AC, then up if you need to. I assume you did not press the on button.
Okay, is it 0.1204?
Yes, exactly. Which is positive, right? So
Yeah.
you put down a plus sign. That's all I need. I don't care about the value. Just just give me the sign. Understand?
Yeah.
What does the sign refer to? Okay,
The
or
sign
what does dy by dx refer to? Begins with a letter G. GR. GRA.
gradient.
Gradient of what? Gradient of a banana. Gradient of an apple.
On a curve.
Ah, okay. More specifically, what of a curve?
Tangent of a curve.
Tangent, which is exactly what I need you to write down as the next row. Right?
Point.
Tangent, then draw the tangents for me. Ta-dum, ta-dum, ta-dum. Negative gradient, zero gradient, positive gradient, final conclusion, minimum point. Yes, exactly. So that means that the curve will look something like this, where the tangent is here, here, and here. Negative, zero, positive. That is method one, table. For the first point, we still haven't done the second point. Wow, very long window, but actually very fast one. I just talked too much. So now, no space, I'll just go below. Draw the same table again. Like this. What is it? X equals to negative 2/3. Okay, x equals negative 2/3. Then in the middle, left side negative 2/3 minus, right side x equals negative 2/3 plus. Then you find dy by dx sign. What's the sign? This one middle always zero lah, huh? You know why, right? How did we get negative 2/3? Where did this come from?
Where did negative 2/3 come from?
Came from a line above. Math questions always like this one. If you write down step by step logically, when I ask you that question, it's just one step above. The answer is one step above. Where did it come from? Came from the step above. Then where did this come from? Came from the step above. Where did this come from? Came from the step above. Set dy by dx equal to 0. But wait, dy by dx equal to 0. That's your answer. Dy by dx equal to 0. Ta-dum. Understand? Make sense? Okay, so always 0. The middle guy always 0. How about the left and right? Can you key in the calculator for me? So that's when it will be advantageous.
I press
on. Then you too bad lah. Ask you don't press on, your hands on. Then you have to pick a value that is a bit smaller than negative 2/3. Let me clarify what the decimal value is. So, sorry. A new charge. Oops. This is negative 0.666. A bit smaller. Is it negative 0.7? Is that smaller or bigger?
It's
7 bigger than 6.
Smaller.
You understand negative numbers. Very good. Okay. Then the other guy, maybe you'll pick negative 0.5. Don't go too far, okay? Don't go too far. You don't go and pick, you say bigger, then you pick positive 10. Don't go so far, okay? 10 to negative 0.6, percentage change is too much. Percentage increase too much. Just go, actually, maybe this is also a bit too much. Maybe just 0.01. So maybe something like negative 0.667. This is negative 0.665, right? Then key in the calculator, then tell me what's the sign. Yeah, I also pressed the on button. Okay.
Yeah, I do the negative.
Okay, sure, I'll do the positive one. Positive 2/3 plus 0.01. All right, and shift store, sub in. Okay, I got a negative.
Yeah, I got positive.
Yeah, oh, positive? Okay, good. So now you draw the what?
Draw the tangent.
Tangent.
Down.
Horizontal.
Yeah, up, horizontal, down.
Down.
Max
Conclusion,
point.
this is a maximum point. Okay, good. So that is method 1. Now let's try method 2. Method 2 is the more sophisticated one. The concept is, I'm just gonna quickly explain this. Whenever you have a happy face, this guy is a minimum point. Let's consider the gradients of the tangents. Very, very negative, slightly negative, 0, slightly positive, super, super positive. d2y by dx squared is the second derivative. You have done all the practices, just differentiate 2 times. But more importantly is the derivative of the dy by dx, which is the derivative of the gradient function. I'm just going to write gradient function. This one can also be interpreted as rate of change. So how fast, you can say how fast is the gradient changing? It goes from super negative to 0 to slightly positive to super positive. If you plot a graph as x increases, what happens to the corresponding dy by dx value? It's actually super negative, slightly negative, 0, slightly positive, super positive, which means that this is a what kind of function? Increasing function. What do you know about increasing functions? The derivative. Oh, sorry, maybe I shouldn't say rate of change. This one is just derivative, just derivative. For increasing function. Increasing functions, the derivative must be more than 0, less than 0?
More than 0.
More than 0. So straight away, conclusion is minimum point if and only if d2y by dx squared is more than 0. This is a mathematical logic symbol. You don't need to care about it. Just know that it means logically equivalent to. It's the same, basically. It's the same. Right angled triangle, a squared plus b squared equal to c squared, a squared plus b squared equal to c squared, right angled triangle, if and only if kind of logic. So minimum point d2y by dx squared more than 0. Then clearly, if you just reflect the argument, I mean just reverse, go in the opposite direction, maximum point will be the same as d2y by dx squared less than 0. So, you can memorize this. How I like to think of it is less than is very sad. Maximum is very high. It's like the opposite. This is sad, this one is max. This one is low, minimum. This one is high, more. Opposite. But of course, that's not a proper reasoning. I actually went through this thought process many, many times and I finally got it. I also advise you to think about it. You can try it for the maximum point on that kind of logic. But anyways, the conclusion is all you need to solve this question. So let's just use it. For the first point, let me copy down so I don't need to keep scrolling up and down. The 2 points. Okay, gotta paste it here. For the first point, you just need the x. Oh, sorry, I forgot. This one is evaluated at x equals whatever is the value. Evaluated at x equals whatever is the value. Okay, so let's just write down the dy by dx first. We already solved it just now under the d step. It is 9x squared minus 6x minus 8. So we can move on to second derivative. So d2y by dx squared is just 18x minus 6. At this point, we want to substitute. So I'm lazy to write English words, so I draw a vertical line, x equals. Substitute with the first x coordinate, 4/3, to determine the nature of the first stationary point. Maximum, minimum, or inflection. So if I sub in, what do I get? 18 times 4/3 minus 6. Do I need to really care about the value? No, I just need to care about the direction, the sign, more than 0, less than 0. Okay, so let's just type in a calculator. 18 times 4/3 minus 6. I get 18, which is more than 0. Conclusion is 4/3 comma negative 35/9 is a what point? PT is point. More than 0. Mike test, are you there?
Yeah.
More than 0, d2y by dx squared means it's a what point?
Increase.
No. It's the gradient function is an increasing function, which implies that this is a what point?
More than 0.
No, the conclusion is here. d2y by dx squared is more than 0 means it's a what point?
Second derivative. Minimum point.
Minimum point, exactly. More than 0 means minimum point. That's it. More than 0 means the rate of change of the dy by dx, which is the gradient function. If it's more than 0, it means that the gradient is an increasing function. If it's an increasing function, what does it mean? Means the gradient will, as x increases, the gradient increases. So from negative, it will increase to 0, then increase to positive. I'm purposely writing it up, going upwards to remind you it's increasing. Gradient is increasing, but more importantly, it's the gradient of what? Gradient of a tangent at a point to the curve. Negative gradient, 0 gradient, positive gradient. What shape do you see? A happy face. Happy face, right? Then what's this point here? Where the gradient dy by dx equal to 0, also known as stationary point. This is a minimum stationary point. Okay? Can local minimum. Okay, I'm not gonna go into the details of what's local and global because you have not officially learned about functions and the domain of a function. So I'll just ignore that, it's not in the syllabus. Just minimum point is good enough. All right. Now, if you're neat and tidy, you will have your d2y by dx squared written down like this. Then you can proceed to substitute with the second point. Which is, let me just write. I don't need the second point. I just need the x coordinate of the second point. I can just write down d2y by dx squared, vertical line x equals to negative 2/3, equals to 18 sub in with negative 2/3 minus 6. What do I get? Type in a calculator, quick. What is your answer?
You get
18 times negative 2/3 minus 6.
negative 18.
Negative 18, very good, which is less than 0, right? Less than 0. Less than 0 means what is a decreasing function? Gradient function. Is less than 0 means that this guy is a decreasing function. Decreasing means what? Gradient is dropping from positive to 0 to negative. But the gradient of what? Gradient of a tangent line at points to the curve as x increases. So this is x equals to 1. This is x equals to 3. This one x equal to 5. As x increases, what happens to the gradient of the tangents at the points to the curve? Positive, 0, negative. Positive, 0, negative. Then the only possible curve that can have positive, 0, negative is a set face. Which means that this point here is a what kind of point? Maximum point. If you find that a hassle, just memorize it. Okay. But of course, memorizing, you're bound to mix it up after you stop practicing for a while. Understanding the concept more important. But yeah, for exam purposes, you can memorize. This point is a maximum point. Okay. Opposite, just think opposite. Less than 0, very sad, negative. But this one, maximum, very high, opposite. More than 0 is very high. This one, minimum, very low, opposite. Okay, 可以吗? Is that clear?
Yeah.
Let's check if it's the same conclusion as method 1. Table method. Minimum point for the first guy, minimum point for the first guy. Same. Maximum point for the second guy, maximum point for the second guy. Same. So both methods work. Clear? Which one do you think is easier?
The first one.
First one, very good. Yes. In fact, the first one is more powerful than the second one because of what's known as inflection stationary points, or just inflection points. Because d2y by dx squared, you cannot conclude anything with what do you call when you cannot conclude anything when the d2y by dx squared is equal to 0. So let me give you an example that's not given in the question. This is known as very important example. Ayo, too big. Important example. Warning. I've only told you 2 things about the d2y by dx squared. Let me just write it in a smaller font. I have only told you 2 things. The sign of the d2y by dx squared after you sub in the x coordinate of the stationary point. More than 0, you get minimum. Less than 0, you get maximum. Those are the 2 things I told you. You got more than 0, you got less than 0. What's the missing link in between? A number is more than 3 or less than 3 or exactly equal to 3, right? More than 0, positive. Less than 0, negative. What's the number that's missing? 0 itself. Equal to 0. Correct or not?
Mm-hmm.
Then the curious student, curious boy will ask, what about d2y by dx squared exactly equal? And after you substitute in x equals to the coordinates of the stationary point, equals to the x coordinate of the stationary point, you get exactly equal to 0. What does that do? What can we tell from that? The answer is no conclusion. You cannot conclude anything. Okay, let me show you an example. And also this example will also highlight that first derivative test is more powerful than second derivative test. And it's easier to do. So you know which one should you do during exam time? Which test? First one. Exam strategy. But depends on you. Sometimes second derivative also quite easy to find it. It's faster. Because if you take a look at this, dy by dx, d2y by dx squared, some students after practicing a while, they will realize, differentiation very fast. Substitute in, so little working. Still, first derivative test still need to draw this annoying table. Don't want. Even though at first glance, first derivative test is easier. It's really subjective. It's up to you. But I would say that first derivative test is a bit more powerful. Let me show you the example. Y equals x power 4. Find SP, determine nature. How? Tell me the 3-letter procedure. D. Your iPad is sitting on top of a table, also known as a desk. Mic test, are we still connected?
Yeah.
Okay, there's. Okay, there's. Can you remember? Okay, so what's the first step? D.
Dash differentiate equal to 0. Solve for x.
Differentiate.
Then
Help me to answer. This is the equation I'm talking about.
okay, for x.
4x what? Power?
Yeah, for x to the power 3
Okay. Then
equals 0.
must say the magic word at least. Set.
For x.
dy by dx equals 0, which implies 4x cubed equals 0. Then, which implies that
Then
x equals
x equals
x
to
cubed
0.
equals 0 over 4. Then you take the cube root of 0 over 4, which is just 0 lah. Don't need. X equals 0. Very good. Now I want the point, stationary point. So I need the y coordinate as well. So y equals
Y equals you sub x back into the y equals 0.
okay, back into this one or that one. Y or dy by dx to find the y coordinate.
Y.
Y, very good. Some students, they very blur during exam. They'll sub 0 into dy by dx. Wrong. No. You must sub into the original y equals x power 4. So you get 0 power 4, which is just equal to 0. Very good. So the coordinates is 0, 0. Is SP. Then des upgrade to des table or second. Table. Let's do table. Right in the middle. What do you put in?
0.
Wanna try? You try drawing on your own. Go. Draw. Must practice. Talk too much. Let you try.
I thought you were like this.
Wrong. Nope, the labels. Oh, yeah, correct. Sorry. Yes. Oh, x equals 0. Correct. Put a x equal. If not, I confused. X equals 0, x equals 0 minus, x equals 0 plus. The label, what is 0? Second row, no label. Y, are you sure it's Y?
dy over dx.
Do you need to write it many times? Just write one time on the left. What of the dy by dx? Do I want the actual value, the nitty gritty 0.17325?
You just want plus or minus.
So sign of dy by dx sign of dy by dx. Be more precise in the row labels.
Wait, how do you do it? You
sign off. Okay. 符号 plus or minus.
Then you say the difference shouldn't be that much, right?
Correct. So maybe go for negative 0.01 and positive 0.01, something like that. Sub in, what do you get?
Okay, sub in. Okay. Negative. Then positive minus plus. Then what is
Hold on. Let me double check. Okay, correct. Yes.
Then
good.
what is dy over dx? And dy over dx is gradient of tangent of a curve. So then you want me to draw just like this, So mean point.
Correct. Very good. Yes. Okay, I'll just fill in the blank. So sine of dy by dx, we end up with negative 0 positive. The top you put down x equal to 0, the x coordinate of the stationary point. Then x equals 0 minus, x equals 0 plus. Then below you write down, draw the tangents. So to set negative 0 positive gradient, which implies minimum point. Okay, actually how the graph looks is something like this. Like this. Oh, not more like a U shape. This is y equals x power 4. Compared to this guy, this is y equal x squared. Okay, it's just a steeper version. Okay, you can go decimals and draw it yourself. So that is the conclusion from first derivative test. How about second derivative test? Can we try that?
I don't like that one.
Second derivative test, just find second derivative.
Okay.
Second, go. d2y by dx squared. Maybe just to help you, I'll copy and paste the dy by dx here. Carry on. Recall the stationary point is 0, 0. Go, go, go. Find the second derivative test. Write it down now. Go, go, go. d2y by dx squared. d2y by dx squared equals to good. Maybe just to help you out, I'll write it down. More than 0 min, less than 0 max. Point. d2y by dx squared. Okay. Upon substituting with, sorry, I keep forgetting this. X equals to so sum. Find this, substitute, then check the sign. 3 steps. Don't want to break it down into so many steps. Let's practice. A is 0. A? 12 times 0 square is 0. Does it fall into any of these categories? No. So what's the conclusion?
Inflection.
No conclusion. We cannot conclude anything. So you see, you spend so much time trying to find second derivative test, but you make no conclusion. I'm going to just write this down neatly. This is a very important example. You need to remember this. So second derivative test will give you problems in certain situations. You cannot get the nature in certain equations. Oops, x equals 0. Okay, very important. No conclusion. It doesn't mean that there does not exist any stationary point and there is no nature. No. It's just that a second derivative test is not good enough. Okay, can? When d2y by dx squared, d2y by dx squared, when it's equal to 0, right, there's many possibilities. In this case, I gave you an example where d2y by dx squared equal to 0 leads to minimum point. There are other cases where d2y by dx squared equal to 0. Sorry, you sub in already and it's equal to 0. You actually end up with a inflection point. Okay. Case in point being, I can't remember an example. I need to go and dig up an example. But just remember, I only tell you 2 things: more than 0, less than 0. Equal to 0, no conclusion. Can? For d2y by dx squared, second derivative test.
Okay, no. Okay.
Equal to 0, no conclusion. All right. Yeah. But practice both ways. Okay, that is so long-winded. I'm so sorry for taking so much time. That was just 1D. 1E, 1F, I'll leave it to you to do on your own, okay? Actually, sorry, let me just quickly do. I realize I still haven't talked about what's that fellow called inflection point now. Let me just quickly check if I should go through. Is it worth going through? Nope. This guy there, 4x times x squared minus 12. Nope. E and F you're gonna do on your own. Let's move on. E and F, do it yourself. It's the same thing every time. All right. Let's go to the next question now. What is it? Question 2B. Okay, let's see what is 2B. Scroll up and find 2B. What's so special about this? Let me double check. Actually, most of them are nothing interesting. It's just tedious work of differentiating. What's so special about this? It's a fraction. Okay lah. I will go through 2b. Can? 2b. Let's go. Can let me know. I'm just gonna go at my normal speed. Is that okay?
Yeah.
Okay, let's go. So here we're gonna deal with 2b. What is it? First derivative test. Okay, good. Don't need to do the first. Don't need to do the second. Find the coordinates of the stationary points of each of the following curves and determine the nature of the stationary points. Coordinates, nature. Please find your x, comma y. Let's go. Question 2b. First step, copy the step 0. Copy down equation. Second step, d, e, s. Second step, just differentiate dy by dx. What do you get? I see fraction, quotient rule. Low d high, less high d low, draw the line and square below. Low is x, multiply by d high. So 2 times x minus 3, bring down the whole power. Differentiate x minus 3 is a 1 to need. So I don't need these pair of brackets. Like this. Less, so minus, high d low. So copy down the top. Differentiate the bottom, get a 1. D low. Draw the line and square below. Square the x. Simplify and clean up a little bit. So what I get is 2x squared minus 6x, right? Because this is multiplication. So it's like 2x times x, 2x times negative 3. Then minus away x minus 3 squared. I'll just leave it alone because I don't want to deal with that expression. Next, I'm going to equate it to 0. Set magic keyword dy by dx equal to 0. What do I get? I'll get that fraction on top equals to 0. I am starting to regret not expanding the x minus 3 squared. Let me expand it first before I continue, because I need to solve for x. So 2x squared minus 6x minus away bracket x squared minus 2 times 3, 6x plus 3 squared, 9. Open up the bracket, I get negative x squared plus 6x and a negative 9. Just swap the sign. 2x squared minus x, and don't forget the x squared at the bottom, x squared at the bottom, x squared at the bottom. 2x squared minus x squared, I get single x squared. Minus 6x plus 6x, they cancel each other off. Minus 9 is just minus 9. X squared minus 9 over x squared. Good. So now at the second step, I rewrite it as x squared minus 9 over x squared. Set it equal to 0. How to solve? Oh no, confused. Don't worry. Divide by something, opposite is times. So bring over becomes a times. Equals to 0 times x squared. But what is 0 times anything? 0. So that means right hand side is a 0. X squared minus 9 equals to 0. X squared equals to positive 9. X equals to plus minus square root 9. Do you need to, plus minus 3, do you need to toss the negative answer away?
No.
No, this is a general question, not practical question. In the future, you'll see x is a length of a rectangle or something. Then you will have to reject negative. For now, don't reject. So x, I like to, when I see plus minus, I get a bit irritated. I would strongly prefer separating it out so that I can clearly see the xy coordinates. So I'm going to sub in x equal negative 3. So sub in negative 3 over here, minus 3 bracket square over negative 3. This is minus 6 bracket square over negative 3. Bracket negative 6, so I get a positive 36 divided by negative 3, which is a negative 12. Okay, negative 12, then I sub in negative 12. Then y equals to, let's sub in with x equal positive 3 this time. So positive 3 minus 3 bracket square over 3. What do I get? 3 minus 3 is 0 square over 3. 0 to the power of 2. That's just 0. 0 divided by 3 is 0. Okay, so I get a 0 over here. The coordinates, if I want to be neat, I can write down negative 3, negative 12, 3, 0. Clear so far?
Yeah.
Very good. We are not done yet. We now need to find the nature of the stationary points. They requested for first derivative test. Okay, so let's proceed. What do you need? First derivative test. Table. Remember delta. D-E-S. Write it. You see des. Then delta. Slash second derivative test. This one don't need to. Just ta. Okay, just ta. Very good. So ta means table. Draw a table. Middle is x equals to, let's just do it for the first point. Actually, this is taking up too much space. I'll just draw it a bit smaller. X equals negative 3. x equals -3 minus x equals -3 plus. So now you have sine of dy by dx. Let's calculate that. What's dy by dx? Dy by dx, I don't know. I forgot, but never mind. I know for sure the middle must be 0. How about the left side? X equals -3 minus. So that's maybe -3.001. This one, -3. Oh no. This one, think a bit. It's -2.99. Right? Slightly more than -3. Number line, here's -3. Here's -3.001. Some students will get confused by this. I hope you're okay. -2.99 is bigger than -3. Okay? Can. Good. Now go back to the derivative. I'm just going to copy and paste it down. X squared minus 9 over x squared. Very good. So paste it over there. Then sub. So I'm just going to key in into the calculator. Let me just share screen with you. I'll type it on the calculator here. So what I'm going to do is I'm going to write a fraction. Then I'll just use the variable a squared minus 9 all divided by a square. Okay, then this will give me nonsense answer. Why? Because I fed 8 nonsense inputs. A is currently 1.34, which is not what I want. I want A to be -3.011. So I'll just set -3.001. Shift store A. Don't press the on. Scroll up until I see this. I press equal. I'll get this bunch of very, very small numbers. 10 power -4 is still positive, okay? It's just 1 over 10,000, if I am calculating correctly. It's still positive. Positive 6.66333, whatever, is still positive. So that just means it's positive. So all we need to write down in our table is a plus sign. I am writing on the iPad. I know you cannot see this. Plus sign underneath x equal -3 minus. So now let's just do it for the case where x equal to a bit more than -3, which is -2.99. So I'm going to type in -2.999. Why not? Shift store A, up, just up one time, sorry. See, it's like a history button. It's like checking the history. You can go forward, you can go backward. Right? You know how to use a web browser. It's similar. Go up, you get to this. You can press the left button like this and then press equal. Also works. More important, you see a bunch of numbers, don't care. More important is the sign. What's in front of the 6? A minus sign. So you write down a negative in front of the correct position in the table when x equals to -2.999. Slightly positive, slightly bigger than -3. Now go back to iPad screen. Yeah, the plus and minus. Just now you couldn't see, now you can see. Right? Good. Draw the tangent line now. Tangent, positive, 0, negative, right? I'll draw another line, make the table look nice. Then the conclusion is, what point?
Max point.
Maximum point, very good. Like this. You don't draw the curve. Okay, I mean you can draw the curve if you want to. Doesn't matter. That is for 1 point. Can I leave it as an exercise for you to do the second point?
Okay.
Exercise. All right, now I need to show you a graph. So remember the function, x minus 3 bracket square over x. Okay, and then we managed to get maximum point for -3, -12. Okay, how about the second point? Now, maybe I should have done this at the beginning instead of just teaching you the algorithm. I'm teaching you the step-by-step procedure recipe. I should have started, instead of doing that, maybe I should have started by doing this. Here is the graph of y equals whatever is the function. Can you see?
Mm-hmm.
Can you tell straight away what's the nature of 3, 0, the stationary point we found? Max or min? 3, 0.
Minimum point.
Exactly, minimum point. So if you have graphing software, you don't even need to do this procedure anymore. Right? Differentiate equals 0, solve for x, sub in x equal to the d2y by dx squared, less than 0, maximum point, more than 0, minimum point. or first derivative test, draw the table. You actually don't need to do that anymore with modern technology. This is more of ancient math. But also the technology that goes behind this the modern software is whatever you're learning now. Okay, finding the derivatives. So yeah, your answer is already known, minimum point. So you go and do the table on your own. I'll leave that as an exercise. Can? It's exactly the same as this procedure. It's just repeating again and again. You need to make sure you get this into your muscle memory. Differentiate equals zero solve. That's very fast. Must be super fast. Okay. Engineering confirm need to know. You cannot say you don't know this. Finding maximum minimum point. Determining the the nature of a stationary point. Yeah. Okay. Good. Let me think. Do I still have time? It's already 10. Okay, let me see what other homework questions were there. 2B is done. Let's take a look at question 3D. 3D, let's see. What's so special about 3D? Okay, I think I just saw that it has a fraction which will make the differentiation a little bit more difficult, and it will be more interesting. This is very interesting. This is a very important question. Okay, let me just show you the graph first before I even continue. Because modern times call for modern solutions. Okay, let's go and use the decimals to look at the graph of this function. Okay, y equals to 2x squared plus 500 over x. Can you see the curve goes this way, downwards? Can, right? But more importantly, can you see a curve? It's actually changing from a left half of a sad face to the right half of the left half of a happy face to the right half of a sad face. Can you see the curvature? It's bending this way and then this way. Just not very dramatic. I'm drawing very bad. Let me change the scale so it's more obvious. Negative 1,000, positive 1,000. Can you see? Oh wait, sorry. I might be doing this wrong. Oh wait, maybe it's not. Maybe I'm thinking too much. Let's see. Oh no, it's a change in the curvature. Okay, this is a very interesting curve. I'm not too sure. Is this actually? Oh, is this actually having a gradient of 0? I'm not sure. Maybe not. It's just a change in the curvature. It's not a stationary point. It doesn't look. Okay, let's just differentiate it and we'll see. Okay, this graph looks kind of interesting. Okay, we'll see. It's just a y. It's just an x-intercept. I'm not sure if it's a stationary point. Let's just do this question. Do you need to rush off?
No need to rush off.
Okay, good. Then I'll just continue. Let's go. Okay, share screen again. What was I doing? Question 3D. Okay. Let's go. So can you tell me the 3-letter or 5 letters? What is it? Begins with a letter D. Your iPad is sitting on top of a
Test. Wait, what?
Testa 2. Not Tesla, it's Testa. Okay, D. Wait, before that, step 0, what is it? Step 1 is dy by dx. No. I don't want that. I want step 0. Y equals, copy the question, copy the equation at the top first. Very important habit you should build. So you won't get confused. carry on, differentiate. I'm just gonna go faster. Is that okay?
Yeah.
Can okay, differentiate x squared, you get 2x, 2 is 4, 4x. This one is 500 over x, bring it up, x power -1. So -1, 500, x power -2. You can also rewrite it as -500 over x squared. The minus can be brought down in front. 4x is in front. Very good. Now we can move on. So equal to 0. So set magic word, dy by dx equal to 0 implies that copy the expression above equal to 0. Oh no, I don't know how to solve this equation. Don't worry. I'll just do the standard procedure. Rewrite this as a fraction. Fraction minus fraction make what the same? Make the denominator the same. So we want x squared. How do you get x squared? The left fraction, multiply top and bottom by x squared. Okay, maybe you already know this. So 4x times x squared is 4x cubed over x squared, then minus away 500 equals 0. Divide, bring over becomes times. 0 times x squared, 0. Left with 4x cubed minus 500. You get 4x cubed equals to 500. Divide by 4, then take a cube root. Divide by 4 first, then take a cube root. Oops, cube root then shouldn't have a cube anymore. Okay? Can? This, just on side note, technically, two complex roots. But this is out of syllables, okay? How you would find those roots is actually to use the special identity. If you remember, what's this guy? Soap. Do you remember soap? Same, a squared, ab, b squared. Opposite sign, so plus. And always positive, so plus. Remember this identity? Difference of cubes?
Yeah.
Yes, so same thing over here. You can actually do that. Here, you could have gotten x cubed equals to 500 over 4. Let's just simplify it first. 250 over 2 is 125, which is really just 5 cubed, right? 5, 5, 25, 25 times 5, 125. So it's actually x cubed minus 5 cubed equal to 0. Difference of cube. X minus 5, x squared, same, opposite, always positive. So x times 5 is 5x, with a plus sign here, and always positive. So 5 squared, which is 25. Factor times factor, if you recall your factor theorem, actually this is just solving equations. First factor equals 0 or second factor equal to 0. Can you see that? Solve the first factor, you get x equal to 5. Solve the second factor, use quadratic formula. You realize that the b squared minus 4ac discriminant is less than 0. Then you have to take square root, so you cannot continue. For now, engineering math, if you're gonna do electrical engineering, you'll have to learn about this concept known as complex numbers. You need to know square root of negative numbers. For now, don't need. Okay?
Okay.
This is the true way to solve cubic. Now this is the lazy Amex way. Just cube root. Never mind. Positive number, cube root. Negative number, just cube root. Do you need plus minus here?
No.
Don't need man. I thought it's got the root then plus minus. No, man.
No.
Only when this is what kind of root?
Square root of root to the power of root.
Only when it's square root, then you need plus minus. Or even roots. Because every even number can be rewritten as a square root. Right? Can factor out 2. So yeah, square root then plus minus. Odd numbers here, you don't need to plus minus, okay? Odd. No plus minus required. Okay, of course, another way to solve this over here, right, is 4x minus 500 over x squared is equal to positive 500 over x squared. Multiply by x squared, so it's 4x cubed equals 500. Much faster, right? Can you see? Minus bring over become plus, then you just times the x squared. That's another way. Then it's as oh sorry. Then it will be exactly the same. It will be exactly the same. Okay, anyways, moving on. This is just second step E. E equate to 0, solve for x. Then, oh, actually, no, S also done already. S, this one, solve for x already done. Cube root of 500 over 4, which is, actually, I can simplify it. 500 over 4 is 125, which is actually now x equal to 5, right? 500 over 4 is 125. Cube root of 125 is 5. Are we done? No, unfortunately, this one asks for coordinates, so you still need to find what? Y. X not enough, still need to find y. So do you substitute x equal to 5 into the dy by dx here, or the original y? Step 0. Which one? Mic test.
Which one?
I want to find the y coordinate. So do I start into the equation that says y, or the one that doesn't say y?
That says y equal to x squared plus 500 divided by x.
Yeah, everywhere there's an x replaced with a 5. Okay, over here to that, replace x with 5. Here and here. Okay, let's just calculate this. 5 squared 25, 25 times 250. 500 over 5 is 100. So you get 150. Is that okay?
Yeah.
I'm going very fast. Yeah. So 50. So sorry, this is 5, 150 stationary point. Are we done? No. This one, the question super long-winded. Determine the nature. Let's go. Let's figure. By this, at this point in time, how many stationary points do you see? Or have you found?
How many stationary points have I found? 1.
Exactly, just one. 5, 150 is the stationary point. 5, 150. Let me share my desktop screen. If you recall the graph, 5, 150 is over there. Can you see? There's a negative 6.3, 0. Is the negative 6.3, 0 a stationary point?
No.
Correct. Very good. Yes. That procedure will guarantee you will find all the stationary points. Negative 6.3, 0 is not a stationary point. Meaning at negative 6.3, 0, the gradient of the tangent line is not 0. If you draw a tangent line, I guess you can roughly change a different color. Roughly over here, if I can make my line pass through that point, this is the gradient. This is the tangent line, and the gradient is not 0. Okay, that's all I'm trying to say. And here, the gradient is 0. The other guy, m not equal to 0. Wow, very messy. But do you get the idea? Can only at this point here. Oh, maybe just clear everything. Only at this point here, which is negative 5, 150. That is your stationary point where the tangent is equal to 0. The gradient of the tangent is equal to 0. Okay, moving back to the question. Not done yet. Still need stationary. You still need to determine the nature. Okay, let's go. I will show both ways. I'll show both ways. Let's go. What's the procedure again? Can you remind me again? What's the 5-letter? What's the mnemonic I give you? Testa. Testa 2. Testa 2. Tatu. Okay, so method 1. Method 1 is what? Ta for draw.
Wait, what?
Ta. TA. Your iPad is sitting on top of the table. Can you draw? Try. Right. One more column for the labels. Yeah.
Wait, oops.
It can also, that also works. Yeah, you sort of factor out the x. Can. I didn't think of doing that. Good. Sine.
Okay, then we can zoom out.
Is that oh, you want to see what is the dy by dx? Okay, I bring it down for you. Wait a minute. 4x minus 5. You know you're trying to find the dy by dx now, right? Not y.
Yeah.
You know, a lot of students will get confused. Y or dy by dx? It's y. Yeah, it's dy by dx. Carry on. Middle one, straight away. Straight away. What's the sign? No sign.
Straight away the sign. The sign is
When x equal to
0.
5, yes, it's 0. No signless, not positive, not negative. And just do like 5.01 or something. 5.01, something slightly smaller, or slightly bigger than the
4.09. Wait, 4.90. Wait, no, wait.
Sure.
5 minus 0.001. Wait, no, 5 minus 0.1.
You could type it into the calculator 5 minus 0.01 if you cannot work it out. Can you have a calculator? I just want the sign.
How do you know if it's too much?
Later that I explain later.
Okay, but anyways, this one negative, then this one positive.
Okay, good. Yes. So therefore you get what point?
Therefore, I get dy by dx is gradient of a point on a curve of the tangent or something.
Gradient of the tangent at a point to the curve.
Point. Gradient at a tangent to the
gradient of the tangent at a point. Where is the tangent? Located at
a point on the curve.
On the curve, yes. At a street in Singapore. It's like speed of a car at a road in Singapore. Gradient of a tangent at a point to the curve. That kind of phrasing okay, you'll go work it out yourself. So yes, you got the right idea. Negative gradient has a downward sloping tangent line. Then 0 is horizontal, positive is upward sloping. So you get a happy face, which is our minimum point. Okay, good. Then you just do the rest. Minimum point. Fill in the blank on your own. Let's try method 2. Method 2, how?
By the rest, what do you mean?
I mean, if you are taking notes, do the rest on your own. I'm not gonna write this down.
Oh.
Yeah. We try method 2. I'll explain later. How much is too much? Like, how much is too much for the 5 plus and the 5 minus? Later. Can you help me to clear the screen?
Yeah.
Yes. Now go on to method 2. What is method 2? After TA, it's 2. What does 2 stand for? The table, you only had to deal with the first derivative. So now method 2, you have to deal with the what derivative? Instead of the first, you deal with the second derivative. Carry on. What is it?
square of dx square equals to d over dx of this thing.
Yep.
And minus 2 times minus 500, 1000x minus 3 plus 4.
Good.
Sub x equals to 0 inside. Okay, sub x equals to 5 inside.
Much better. Not 0.
Yeah,
It's
5.
equate to 0, not that was the E equate to 0. Don't sub in with 0, okay?
Okay, so
5.
12, which is more than 0, means that it is increasing. Wait,
What is increasing?
increasing function.
What is
So
increasing function?
As the gradient increase, the thing also increase.
What is an increasing function?
As the thing
I'm asking
increase,
for a noun. What is an increasing function?
rate of change of gradient. Wait, what? What?
The gradient function is an
Uh,
increasing function.
okay.
Okay. The gradient function is the dy by dx. Right? Two names are gradient function or rate of change function. I'll write this down. Gradient function is the one you need to care about right now. Rate of change function is the previous topic. Gradient function. So you're saying, this one you sub in, you get a positive 12, right? Which is more than 0, which means that d by dx of that guy more than 0 implies that this guy that I underline is an increasing function. But this guy is a gradient function, right?
Yeah.
Gradient function is increasing function. So can you give some examples? How does a graph of an increasing function look like?
Upward.
Upwards, okay. Then, what's the y coordinate here? It's capital Y equals to dy by dx. I know I've never shown you this, I just randomly show you this. But yes, your y coordinate can actually be a derivative. It can be a dy by dx. And in this case, it is really just 4x minus 500 x power negative 2. X-axis here. So increasing function means it will go from where to where to where. This part is below, this part is on, this part is above x-axis. So in terms of their sign, below is what sign? Negative. And here is 0. And as you keep increasing the value of x, its corresponding y coordinate value is positive. So maybe like here is, if I just extend my y-axis, this could be like, how do I phrase it? This point, and this point. This guy is like -3, -100. This point is like, I don't care what the x is, it's just some positive number, and then positive 100. And this is 0, 0. Let me draw the arrow nicely. 0, 0, 0, 0. So the y coordinate here, -100, 0, positive 100, represents the gradient, which is increasing. What does a -100 gradient look like? You go from left to right, left to right. -100 gradient of a tangent. Down. And 0, how does it look like? 0 gradient.
Flat.
Horizontal. Hey, don't erase the downwards sloping. You must go from left to right, just like the first derivative test. Downwards -100, 0, and positive 100. So what's the curve that has this kind of pattern for the minimum point? Exactly. So just now you already found out d2y by dx squared sub in x equals to 5, not 0. It's equals to 12, which is more than 0. Finally, you conclude minimum point. Clear or not? Opposite. More is high. Minimum is low. Opposite. Can?
Okay.
Yes. Method 2. All right. Done. I still haven't shown you an inflection point. Let me find an example. I'm going to Google for an example. Sorry. Okay. Let me see. Let me see. Okay. Right. No. Okay, this is a bit difficult. X cubed minus 6x squared. Yes, I finally found one example. Okay, cubic curve, yes. And this one is I need a new page. Okay, this one, inflection point example. Because I haven't shown you inflection point examples. Okay, I will explain that concept of too big, too small soon after the inflection example. So let's start with this first example. Y equals 2x cubed minus 6x squared plus 6x minus 5. Okay, let me show you the decimal screen here. Okay, this is how the graph looks. Can you see?
Okay.
Something like this. Yeah, so there's an inflection point over here, 2.145, 0. Okay. Yeah, this point. I think so. Wait, I might be wrong. No, sorry, I'm wrong. That's not the point. That's not the point. 2.145, 0 is the x-intercept. And there's a 0, -5, which is a y-intercept. I think there is a inflection point over in the middle over here. We need to work it out. Why is it an inflection point? Because what happens to the curve? What do you see? Maybe I change the scale to make it more obvious.
I mean, from it's both increasing, but I don't know.
-0.2 to +0.2. Okay, that's a bit too much. 1 to -1. Can you see what's going on here?
Increase and increase.
Increasing. More importantly, the curve here is which part of a what face? This left half is it's part of a what face? Happy or sad face? This left half.
It's part of a sad face. Then the next part is part of a happy face.
Yes, correct. So that means it changes. The emotion change from sad face to happy face. Then that will be a point of inflection. The formal way to say is change in the curvature. Okay. Let me just zoom out. This is how the graph looks like with this scale. Okay, like this. Okay, so we are gonna figure out that the coordinates of that point. I suspect it's 1, something. I'm not sure. I need to differentiate to figure that out. Let me just go back to my iPad screen. Right. Forgot the word. Oops. Okay, so anyways, back to the example. back to this question. So y equals 2x cubed minus 6x squared plus 6x minus 5. We're just gonna follow the DESTA procedure to figure this out. DESTA table or second derivative test. I'm just gonna use the table method. I'll show you how the second derivative test is inconclusive. No conclusion. Okay, let's do it. So dy by dx is your first step, right? So you get 2 times 3, 6, x squared minus 6 times 2, 12, x, 2 minus 1 is just 1. Don't need to write power 1, plus 6. Constant differentiate, you get 0. Then, oops, sorry, I shouldn't have put a square there. Then you just set dy, okay, technically I should say, for SP, dy by dx, set dy by dx equal to 0. This implies 6x squared minus 12x plus 6 equals to 0. I'm just going to divide by 6 throughout. So I get x squared minus 2x plus 1 equals to 0. Here, it's not so simple to factorize, so I'm just going to use a calculator. Oh, wait, hold on. It's actually very simple. It's just x minus 1 squared, right? Correct? Good. Okay, now we can solve plus minus square root of 0, which is of course just plus minus 0, which is just 0, because 0 is neither positive nor negative. So it is just 0. Solving, we get x equal to 1. Okay, good. Are we done? No, we need to find the coordinate. So we find the y. Sub x equal to 1 into which one? Y itself or dy by dx? Y itself. So we get 2 times 1 cubed minus 6 times 1 square plus 6 times 1 minus 5. Let's calculate this. 2 minus 6 plus 6 minus 5. Oh, it's a negative 3. Interesting. Good. So we end up with the stationary point 1, negative 3. Now we determine the nature. Remember, that's not enough. We need to upgrade to DESTA. Table. Let's become DESTA. Now for table. Just sign is enough. Okay, not enough space. Control Z, undo. You need space for tangent as well. I need space at the bottom for tangent. Just write sign. I understand what you're saying. Tangent. Carry on. Oh, you need the derivative. Let me copy it down. Oh no.
My iPad.
Huh? Sorry?
Positive.
Good.
Positive.
Good. So do you have a sad face? Do you have a happy face? Don't have. So conclusion, it must be stationary. Inflection point. Okay. So actually, let's just list down all the possibilities. Let's list down all the possibilities. X, sine, dy by dx sine, tangent. There's only a few possibilities, right? The middle is always 0. Whatever, let's call it A, is A minus, A plus. So I'm gonna copy and paste this like 4 times. These are the 4 possibilities. put it at the bottom. Okay, let me copy down one of them. And then over here, I'll just fill in the blank with, I'll just copy down whatever you wrote down. What is it? X equals to 1, right? So 1 here, 1 minus 1 plus. You get the sign, positive, 0, positive. By the way, I like to purposely draw it like this. Do you see that it's increasing? I didn't draw it at the same height like this. I purpose, oh, can you see? Or is it blocking? I purposely draw it like this in ascending order so that I can see the curve very nicely. You get what I'm saying? It's to help with the visualization of the curve. Tangent here, tangent here, tangent here. And it shows more understanding that this is tangents at different points of the curve. A point here, a point here, a point here. Tangent, tangent, tangent. Okay. Okay, let's just fill in the blank with, okay, that's it for first derivative test. Let's fill in the blanks with all 4 possibilities. Can you help me to erase your screen? Yep, clear your screen so you can see better. Okay, so these 4 are the 4 possibilities. Okay. Oh, hey, sorry. I just write down the conclusion first. Inflection point. 4 possibilities. Let me use blue color. Plus, 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 minus, minus, plus, minus, minus. Make sense or not? These are the only 4 possibilities. If you've done probability, you have seen this kind of tree, right?
Yeah.
Right? Plus, 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 minus, minus, plus, minus, minus. 4 possibilities. Right? It's a tree diagram. It's a tree diagram. Very useful. You will see this in math a lot. But of course, the table format is also very fine, also very clear. Plus, plus. So draw the gradient. What will it look like? Positive, positive, and 0 in the middle. Other one? You want to fill in the rest on your own? Try first.
Wait, other one.
This one. And this one. And this one. Draw the tangents. Good. Yep. Okay, let me just copy it down. So, right, quickly copy this one, 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 and then this one. Okay, tell me what's the type, what's the name for each of these points? Top left, this one is what point? Help me to clear your screen. Top left is what point?
Inflection.
Inflection point. I'll just put I and F. Apostrophe N. Then the top right.
Max.
Okay, bottom left.
Mean.
Bottom right.
Inflection.
Inflection. Yes. So there's no difference between the 2 inflections. So these are the 4 possibilities. It's just one of the 4 options. Wait, I got recording. The one recording. I'm already recording. Yeah. Okay. These are the only 4 possibilities. Just draw the table accordingly. Okay. Guaranteed 0 always in the middle. Yes. So now, second derivative test. Okay, let's go through it. It is inconclusive. I will show you. Okay, why is it inconclusive? Let me copy down the necessary information first. This is y equals dy dx equals. We want to do what? Do second derivative test. So differentiate. You get 12x minus 12, right? The point was 1 comma negative 3. If you sub x equal to 1, you end up with d2y by dx squared, vertical line x equal to 1. I didn't even have to say sub x equal to 1 because of the vertical line, okay? Which is 12 times 1 minus 12, which is equals to
0.
What's the conclusion? Next point, minimum point?
No conclusion.
Very good. It was a trick question. None of the above. No conclusion. Not maximum, not minimum, no conclusion. Does it mean it's not a maximum? It's not a minimum? No. It just means we don't know anything. Okay? Can? So, moral of the story, which one is more powerful and useful? First derivative test or second derivative test?
First derivative test.
This one, pure mathematicians will disagree because second derivative test is more rigorous. First derivative test is not so accurate because you're testing with a random smaller than and bigger than number. And now finally back to your question, how much is too much? How much is too much? This only matters when the equation has more than one stationary point. So I need to find a good example first. This one, okay. Let me just copy down the x minus 3 square over x graph. Let me just cheat a bit and use decimals to help me draw the graph. Give me a second. Can't remember how it looks. X minus 3 to the power of 2 over x. How does this graph look? Okay, it's a rationale function. So like this, there's an asymptote at x equal to 0 because you cannot substitute x equal to 0. And there are two turning points. Let me just double check. One over here and one over here. They happen to, there's also an oblique asymptote. Maybe I should draw that in first. Oblique means slanted. And a turning point here and somewhere here. Then you can draw the curve. Missed the point. Let me draw it a little bit better. Curve and curve. Let me just get rid of this part. Yeah, okay, good. So this is how the curve looks. Happens that the stationary point here is also what do you call it? X-intercept. Okay, just a coincidence. This is a weird looking curve. You are not supposed to know yet how to draw this. Only H2 max. Then you'll learn this. H1 as well. A-levels. But anyways, this is how the graph looks. And let me label the coordinates of the points. This is 3, 0. Right, if you remember, this was a previous question we did. Not sure if you remember, but yeah. The other point is -3, -12. Okay. Can. So when you're doing first derivative test, what you're doing is you're sort of drawing tangent lines, and tangent lines like this. You're drawing tiny little tangent lines around the point. Okay, like x equals to -3.001 is actually over here. Then what you're doing is, let me get rid of the tangent because it looks a bit ugly. And let me just improve the drawing a little bit because it's not so accurate. Just drop down straight away. What's going on is when we have x equals -3.001, what we're doing is we're sort of plotting a point here downwards until we reach this point on the graph. Okay. And then we are drawing a tangent line, a tiny tangent line here. And then we are measuring what is the gradient. It happens to be positive. Okay. Then we have x equals to 3 here. We drop it down until you hit this point. Maybe I'll use let me try a different color. Try orange. Let's go to 3. Then you drop down until you hit this point. Then you have a little tangent here. What's the gradient? Happens m equals to 0. Then we pick x equals to, I need more space. Let me move upwards. X equals to 3.001, right? Then we go a bit downwards until we hit the graph here. Then we draw a tangent line and we measure the gradient of the tangent. Happens that the gradient is a negative value. Is it clear so far?
Mm-hmm.
So first derivative test is just converting this picture into a table format, which we have already done over here. Plus 0, negative. Positive gradient, 0 gradient, negative gradient, which is just here, here, and here. Can you see? Right?
Yeah.
So your question is, how much is too much? 0.001 is not too much. But if you pick, let's say this coordinates is, what is it? Sorry, I just realized I picked the wrong point. It's not 3. It's -3. So I labeled wrongly over here. This should be a -3, sorry. Okay, and there should be a -2.99. Oh no. Okay, sorry for the error. The values are changed to the correct ones. So the question is, how much is too much? If here is -3, there is +3, then you better don't choose +6. Make sense? If you pick a point that's +3 here as your if you pick x equal to 3, then you measure the gradient is m equal to 0. What you end up with is a table that looks like x sine tangent. Can I just write 10? I hope you understand. If you pick x equals -3.001, x equals to -3, and then x equals to +3, you end up with 0, 0, and then negative. So it's like down 0, 0. Then what kind of curve are you getting? Inconclusive. Why? Because you went too far. Because you went into the, what do you call, the next stationary point that's just beside it. There's one stationary point here. There's a second stationary point. You will need to make sure that the increment, you see here you plus 0.001 and then you minus 0.001. You need to make sure that this increment that you change is smaller than the distance between the two stationary points. -3 to +3 distance here is 6. So you make sure it's less than 6. Does it make sense?
Yeah.
In fact, you can't even go beyond 3, because here happens to have a asymptote. If you go to, let's say, if you pick instead of 3, let's say, let me just write it in, let me just highlight it. Okay, 3, 0, and negative, this is bad. What if instead we pick, let's say, +1? Does that work? So this time it's -3 to +1 is +4 only, right? Would that be okay? Let's take a look at the graph. Where is x equal to +1? Can you draw the graph of x equal to 1?
+1. Wouldn't that be like?
Where is it? Yes, exactly. So what would be the intersection? Can you label the intersection with the blue curve? Good. What's the gradient of the tangent? Going down, right?
Down. So,
negative. So, oops. Just
so say it's an inflection point.
So that means that you end up with what is it? Negative sign and downward sloping. Then you get inflection point, which is wrong, right? Look, x equal -3 is clearly a maximum point. You went a bit too far. +4 is too much. So to answer your question, how much is too much? Why is 0.01 small enough? The answer is, it really depends on the question. Depends on the nature of the graph. Got vertical asymptote, you cannot exceed the vertical asymptote.
Wait.
Second stationary point, you cannot hit that stationary point. So a safe answer is 0.001.
Then the one where you do second derivative test, right?
Yes.
If equals 0, then no conclusion.
No conclusion, yes.
Then how do you know if like it's an inflection point?
Then you make sure that your choice is very, very small and you do first derivative test. You get two of those 4 cases. Remember the 4 cases?
In the end, you still do the first thing.
Correct, exactly. At the
in the
end
end,
of
you
the day,
still go back to this.
First derivative test, correct. You have an option during exams, which one you want to use. First derivative test always works.
But if you get no conclusion, then
You
why
need
is
to
the
do first
second
derivative test.
the second one? I mean, the second one is considered better than the first one because
Oh, because it's easier to differentiate. Look carefully, you see.
because it's
This
easier
is
to
quadratic.
differentiate.
You differentiate
Mm.
12x minus 2, 12x minus 12, sub x equals to 5. Look at the sign. Conclusion. That's quite fast. No?
Oh, okay, true.
Differentiate,
Oh,
sub, get a number, check is plus or minus.
okay,
Then you
but
can
if it's
calculate.
no conclusion, then you still need to do the
You
first
end
one.
up wasting time. So it's a gamble. Correct or not? In terms of exam strategy, yeah, moral of the story, just use first derivative test. Okay? Yeah, but the option is available to you, second derivative test, just to let you know. Yes, I'm done. Okay, the rest you haven't
And
do
all of
as
this
homework.
is just to find out if mean point or max point or
Correct, just to
inflection
determine
point.
nature. Yes. Why? Because it's very important. Maximum and minimum will help you to imagine if this function is the cost of a business function. The cost to a business. You want to minimize the cost, right? Then you want to find the correct cost. Or it could be a warehouse. You're trying to determine, my warehouse, I need to keep a lot of materials, quantity. You can imagine the y-axis will be the quantity in a warehouse, and x will be time. At which point in time should I order a new supply? So my quantity is depleting. My new orders are coming in. At which point of time should I buy a new product so that I can have an increase in the quantity before it drops down again? Then increase in the quantity, and it drops down again. What is the maximum duration? What's the maximum duration? What's the maximum duration that I can wait for before I buy it again? And you must also account for what's called the lead time. Every time you place an order, you need to wait for it to deliver to you, right? So you need to account for that as well. And also, in a business setting, if you buy too many things, the warehouse not enough space to keep the things, then that will be a problem. So what's the optimal quantity of goods you should buy while keeping account of the amount of storage space you have? Or you could be, imagine you're buying seafood, you're a seafood importer. You need to keep it fresh. You need to keep it in a refrigerator. The more you import, the more electricity costs that are incurred in trying to keep the food fresh, right? You need to buy more refrigerators to keep it, buy more freezers. So you want to minimize all these costs. The reason is because it's very important. Okay? Minimum, maximum, very important. Maximize profit, minimize costs.
So later when there's like problems, like how there was a rate of change is gonna be like those time.
Yes, they will start with a cost question, then differentiate equals 0, solve for x, determine nature, is it maximum, minimum? Yeah, then the difficult part will be, okay, this part is the easy part, the mechanism, just differentiate equals 0, solve for x.
Okay.
Later, you just need to add on the start with the first equation. Remember the step 0 over here. Y equals something. Here is very nice. All the questions are very nice. They start off with giving you y equals. Later in the word sums, problem sums, you have to come up with your own equation.
Are you serious right now? Okay.
They'll give you cuboid, then they'll suddenly have this is a loaf of bread, then find the volume of this thing. Find the maximum, then you want to make sure it's a x height. Then what's the minimum height? Or you could have a piece of metal that's going to be bent into a can. If you're a business, you want to minimize the amount of material you use to produce it, right? Then you have a variable height here. What should be the optimal height such that you can maximize the volume, how much food you can put in, while minimizing the amount of material you use? What's the best height? That kind of question. Then you have to get creative with you need to know your mensuration, all your formulas. Volume, surface area, everything must come together so that you can create your first equation. That will be part 1 of the question. Then part 2, part 3 onwards is whatever you've been doing. You need to start practicing. If not, you cannot solve. Okay? Okay? Let's start. Let's start 2. Keep practicing. Okay?
Let's start 2.
Yes. Yeah, that's all.
So fun.
practice until you can get it very fast. Muscle memory. That's all I have. Thank you.
Hey, thank you.
Bye-bye.
Bye-bye.
Go practice. Have a, yeah. Have a